Hello YouTube viewers, welcome to my show Science Thursday. In today's episode, we're gonna take a closer look at laser cutter, an overview. So let's dive right into it. Now, first we have to understand why the heck we need something that fancy, laser cutter and all that. Basically, we cut material for almost all our industrial needs. Basically, it's not something that we can afford to have. Like it's something that we must have. So in those scenarios, you also have to understand that because now we are doing what we classify as mass production. Basically, like this is an old 1940s photo of basically fighter jet manufacturing. They were like 1940 or 60. So they are making like hundreds of these. So whenever you are talking about something like that, where you are mass production, you are producing hundreds of something or millions of something, in those scenarios you need basically precision and accuracy. Accuracy simply means if you say 1 centimeter, it is 1 centimeter. Precision simply means if you are measuring it like 1 centimeter now, 1 centimeter now, 1 centimeter, all of them will not drift over time. So these are two independent things, but again, if you want to do mass production, these become the most important thing, because again, we have been manufacturing things as early as like 1500s, but that's the problem. Like if you are making, let's say, one Eiffel Tower, that's not an issue, but let's say you are building mobile tower, it is an issue, because you have to make sure every component of the mobile tower works with like every other component. So in those sort of scenario, precision and accuracy becomes an absolute necessary, and world runs on it. Like, so you can take an angle grinder and cut a metal, that's not an issue. It's just imagining doing that like millions of times. So that is why we need something that can do laser cutting. Now the first thing, whenever I say computer control cutting and all that, the first thing you will think of CNC mills. Now why the heck, instead of this, like this is even older than laser, why the heck you want to avoid this time tested technology? Well, first of the biggest hurdle that these sort of technology faces is that because there is physical interaction between these two puppies, basically the moving part and the static part, they have what we call a very high work holding requirement. Basically you have to clamp these things down hard, and I mean seriously hard. And is sometimes if you are doing something fancy cutting, you also have to leave what we call tabs. Basically these things make sure that your object does not move around. So you can understand that, like just cutting itself, like you may be like, okay, 500 watts of spindle power is not enough, let's put 2 kilowatt spindle. Awesome. Will it do the job? Awesome. It's just that the moment it starts to go through the material, it will remove the material itself, so you have to clamp it down. So that's a very difficult thing. And not to mention, if you try to do this with thick material, it's okay, but if you try to do this with thin material, the fact that you are going through, you might warp it. Now that is a very bad situation if you are making, let's say, a computer case. In those sort of scenario, you don't have the luxury of very thick material. Thin material will not like you, like grinding through it. And not to mention, we also want to reduce what we classify as thermal stress, because even though, like let's say you have the latest and greatest spindle motor, latest and greatest mill that is like doing the actual grinding, it will still heat up the material. Now again, it will not be an issue, but if you are doing hundreds of this, it will become an issue. And not only for the material that you are cutting, but also for the drill bit, that also will not last if it heats up too much. And you can easily see many of the CNC machine comes with liquid coolant directly running for, so you can understand we want to minimize that. And many material will simply change its property. Not only that, they will also change the size, because in engineering, whenever you are talking about measurement, you also have to specify the temperature. So, and any experienced machinist will tell you, like let's say you are grinding something, you cut something, and you're like, don't measure it right now, it will be hot, so wait like few minutes, because every measurement is temperature based, specifically with metals. So if you say this metal, let's say, is 1 inch thick, 1 inch thick at what temperature? Because if it's 1 inch thick at 30 degrees Celsius, it will be different thickness when it's like 20 degrees Celsius. So you have to consider that aspect. So that makes the like this aspect, thermal stress, much more important. So, and we also want clean and accurate cut. By inherent design, the way it works, like even the best end mill will leave a very sort of rough finish, especially on thin materials. Like on thick material, it has enough grip, but on thin materials, it generally don't do a very good job. Basically, you have to what we call deburr the whole thing. Basically, you have to grind it. So that also adds an extra step for your process. So that is why we want to use laser. We don't want to clamp down the material very hard. That makes it very difficult. We want to reduce the thermal loading, and we also want a clean and accurate cut. We reduce another steps of breaking, chamfering the edges and all that. So all this is possible because of CNC. Now CNC is a very kind of misused term, so I would like you to pay attention to whenever you are using the word CNC. CNC simply means computer numerical control. That's it. So whenever I say CNC, the first thing you will think about like the machine that I showed previously. Now those are CNC mill. Whenever you are talking about CNC, you are basically talking about everything. CNC is the 3D printer. CNC is the laser cutter. CNC is the laser engraver. CNC is the plasma cutter. So CNC simply is the backbone behind all these machines. So do not think of CNC as like, okay, it is something. It's just backbone everything. It's like saying bone. Okay, bone of what? Bone of a dog, bone of a human, what? So that way CNC is a very critical component, and this is what allows user to talk to the computer and computer to talk to the actual machine. So that numeric control is the critical aspect, and it makes everything easy. Because let's say you want to cut out a circle, so you're not gonna be like old milling press that Bridgeport we used to have. Is like you have to like do fancy things or create a jig, supporting jig that is moving the joysticks, because they had power feed back in the day. So using that you can get a circle out there. Now all you have to do is tell the computer print a circle. It will take the command, it will make it into a G-code. G-code will be sent to the numeric control of your machine, and it will be like, okay, I understand what you want me to do, and it will do it for you. So that is the main whole core component of the industrial world today. So it is the backbone system. Now if you have a, let's say, very powerful laser, it's like latest and greatest, very powerful, gets the job done, but the numeric control, basically the CNC is not precise enough, it's gonna have a sloppy control. It does not matter whether it can it does have a recoil or not, because CNC is just motors, controllers and all that. So all of them have to be good. So CNC is a completely independent part. Now many times you will find people who have invested a lot in CNC machine, they just upgrade the cutting bits. Basically they will upgrade the spindle motor, they will upgrade the plasma cutter or lasers, but they will not touch the CNC because if it's that good. So CNC is a very critical component. We just overuse this word with CNC mill. So that is why like people generally don't understand whenever you are talking about CNC. And many companies who are build a mail order, basically you will tell them what you want and they will build it for you. They will like literally give you basically CNC grade 1, CNC grade 2, CNC grade 3. Basically at grade 3 it has like a multiple recovery options put into it. So okay, that's the moving aspect. That's how you're doing the moving. You are using the motors and controllers and all that. So let's talk about the laser aspect. Now laser is the main power draw. Now this is one of those things that are a bit hard to grasp on, because whenever you're talking about laser cutters, people will say, oh, it's a 5-watt laser cutter. Oh, it's a, like in case of industrial, it's 1.5 kilowatt or 1500 watt. So you will think, okay, that's not too much, but his lasers are idiotically inefficient. So if I talk to you about like, hey, I want 100 watt of light output, you will give me a LED strip that consumes, let's say, 105 watt. That's it. Like it is that efficient, LEDs. However, whenever I talk about like, okay, I want 100 watt of laser output, the power consumption will be 3 to 4 times more than that, if not even more. So you have to understand the power consumption of lasers are ludicrously high. So even if like as low, yes, I'm using the word low as like a 1.5 kilowatt, you will have to spend around 3 to 8 kilowatt of power. So that is the main tricky aspect. Like this is the main power draw, not the machine that is moving all the gantry around. Now generally for industrial reason we use CO2 laser. Why? Are there better lasers? Yes. Are there cheaper lasers? Yes. But CO2 has met all the criteria. Yes. And if you want to do more research, I would urge you to look into Wikipedia. But that's the whole point. Like it is safe enough, it is reliable enough, it produces spectrum. Basically every laser has an output spectrum. Basically what is outputting? Red, green, infrared, whatever have you. Infrared, CO2 outputs infrared. So, and infrared reflecting is also very easy. You have to also understand this aspect. If you have a, let's say, kilowatt of laser power, you put a mirror, it will punch a hole through it. So how the heck you reflect it? Basically that is why we want a specific laser whose output is reflectable. Every element on the periodic table has this kind of property. Think of it this way, like how ozone blocks the ultraviolet, but nothing else in our atmosphere. Like nitrogen lets it through, water vapor lets it through, but ozone is like, no, you shall not pass. Same happens with laser also. If you have a very specific frequency, there is a material on earth that should be able to, in principle, able to reflect it with 100% efficiency. So generally we use gold foil for CO2 lasers because it's an infrared spectrum. Now can you use aluminum? Good luck, because it will over time, again, it won't be like you turn on the laser and it's like poof, there's a hole there. It will take time. But again, if the spectrum is, let's say, ultraviolet and then you put aluminum, good luck. So you have to understand and transfer. Now this is the tricky part, because if you buy, let's say, low power laser engraver for child purposes and all that, you can get to something like this, which generally has a laser diode directly onto the moving part. Now that's a very low power affair, barely consuming 5 watt or 10 watt. Like you can see laser output is barely few watts, but it still requires a cooling fan because the thermal output will be so high. So when you are talking about something, let's say, that can cut through acrylic, which is like 300 to 500 watt range, the laser becomes huge. CO2 gas lasers are huge. So what they do is to place it somewhere else. Like you have the machine, you will place it somewhere else, and using mirrors, you will bounce the laser. So these mirrors are very expensive. You have to make sure they are aligned to very high precision, and then there is a focusing laser. Yes, you can focus lasers also, but again, that also means over time the lens itself will erode. Even the best lens will erode over time. So this is the whole system. Now, does laser cutting system have some limitations? Well, yes, absolutely. The biggest limitation in the early days was the cutting thickness. Basically, if you want to make, let's say, fancy pattern for, let's say, your Corsair or Cooler Master, and you want to make fancy patterns for your sheet metal that you use for computer case, awesome. But let's say you are some company who's building like giant lathe machine and all that, and you want like cut through thick material, yeah, laser is like, no, I cannot touch it. For those sort of scenario, people generally go to plasma cutter. Plasma cutter can handle very high thickness, like it can cut through 1 inch of thick material. Laser at that point is like, no, I can't handle less. So generally laser are limited to thin materials. Now it's not because of physics. Be mindful of that. Physics is not the saying like you cannot do that. There is simple physics. It's just you have to put so much power input that running cost will become too high. On top of that, even though plasma is much more inefficient in terms of energy uses, it's very cheap. So capital cost is very low. Here the capital cost is ludicrously high. And if you buy, let's say, 6 kilowatt, which nowadays are the new standard, 6 kilowatt lasers, they can cut through very thick materials, like thick materials that if you told anyone like 15 years ago that laser can cut through that, people would have laughed at you. It can be done. It's just that the power requirement is too damn high. On top of that, machine that can handle that is even much more expensive. So that is the reason we generally, like, if you want to cut thick material, people will simply say either say water jet cutter or get a plasma cutter. That's it. Like, don't even think about laser. Laser is awesome for thin materials. Now, low efficiency also makes it running cost high. It's not something like, oh, I bought it now and now I don't have to worry about it. It's not something like, that has a return, like same way solar farm has. Like, it's very high capital cost, but does return your money. This does not do that. So people are like skeptical of this. Like, CNC mills are relatively cheaper. Now, expensive running cost is also the final nail in the coffin, because the glasses that it takes only 1 inch diameter, or sometimes even smaller than that. Those are very expensive. They are very expensive, like they have actual gold on top of them. So you can understand it's very expensive. The overall system is expensive. So unless you are in a scenario where laser absolutely meets all your requirements, people generally don't try lasers. So this was my presentation and overview of laser cutting systems. I hope you liked it, learned from it. In that case, please click the like button. If you didn't like it, didn't enjoy it, I would urge you to press dislike, press it twice to show me your extra disappointment, and please leave a comment because I reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.